As a follow-up to talking about ionic compounds, one thing we need to talk about is how we know what the charges of the ions are going to be. There are patterns that we can see in the periodic table, and this is a figure from your textbook that shows some patterns that you can see for ions and what ions you expect to be formed from particular atoms in the periodic table. So one thing you'll hopefully see to start with is group 18, our noble gases, do not form ions. So you will never see anything in that column of the periodic table show up as part of an ionic compound. It just doesn't happen. We'll get into why that is as we go throughout the course of the semester. And we'll also get into the why the particular charges we're seeing here on this periodic table are the way they are. But for now, this is a guide to help you. And so for the first two columns of the periodic table, for group 1 and 2, for the alkali metals here and the alkali earth metals here, group 1 and group 2, the charges of these are just the group number, and they're going to be positive ions. So these are, again, just as a reminder, we call these cations. Those are our positive ions. And the left-hand side of the periodic table, the metals all form positive ions. So anything that's a metal will not form a negative ion, generally speaking. We're giving you the usual case here. There are some exceptions. Just like there are exceptions to most of the things that we're telling you in this class, but we're giving you the rules that will work 99% of the time. So all of our elements in the first column of the periodic table form +1 ions. So we can see that here with H+, lithium+, sodium+, potassium+, etc., etc. As we go to group 2, they will form +2 ions. You notice we skip beryllium. Beryllium is not a very it doesn't form ions very well, so we can ignore that one. But that's not a big deal. But just remember that things in the second column will form +2 ions. Now, we'll skip past the transition metals because, as you can see, the rules are not quite as simple here. Many of these transition metals form more than one possible positive ion. They're all positive, but there's not as much of a clear trend here. And so with these ones that form multiple different positive ions, you usually have to specify which one you mean when you're thinking about an ionic compound. So there's a few that only form one ion, and those you'll start to learn, things like silver, aluminum. But we'll look over here at the anions on the right-hand side of the periodic table. These are all of our negative ions. And these you can sort of count from the noble gases. If you go one to the left, these all form the halogens here. I think I forgot to mention their name in my periodic table video, but this group 17 is known as the halogens. These all form -1 ions. So F-, Cl-, Br-, I-. So these are all -1. As we go one more column over, we get to the -2 ions. So oxygen, sulfur, selenium, and tellurium. And then one more row over, we get the -3 ions, nitrogen ion, and the phosphorus ion, nitride phosphide. And so these are some general trends that you can look at to know what charges you should expect for ions. This will be really useful. Now, this is the ions that are just composed of a single atom that has come to be charged, whether by losing electrons, so that's the cations, those have lost electrons, they lost the negative charge, or by gaining extra electrons, those are the anions. In the next video, I'm going to talk about a second group of ions that's really important to become familiar with, which are the polyatomic ions.